Yeah, the first part. So we have three parts. The first part, 3 selected questions from quiz 1. Second part, 5 selected questions from quiz 2. Part 3, 4 selected questions from homework assignment number 1. Yeah. Because quiz 1 is very easy. Yeah. So even I select these 3, also, these 3 also pretty easy. Yeah. Yeah. I hope you did well. Quiz 1. Yeah. Yeah. Number 5. Yes. Yeah. But I want. So this is a simple question. Through this question, I like you, in your mind, you need to have 2 types of equations you can solve. Yeah. One type, y prime equals f y over x, this type. Yeah. Remember, we make this u, right? Yeah. So this type you need to solve. The second type, y equals f of ax plus by. This type. And you make u this part. Yeah. All right. Yeah. Yeah. U that part. That. Yeah. For this case. Yeah. So the u prime equals a plus b y prime. Yeah. So y prime equals u prime minus a equals f of u. All right. Yeah. So now, yeah. So y u prime equals b f of u plus a. Yeah. Now you can, it's a separable. Yeah. So these 2 types you need to be familiar with. Yeah. Okay. Yeah. So in our midterm, I need to give you at least one of the 2 types. Yeah. Yeah. 2, too much. Yeah. If I give you 2 such questions, yeah, that's too much. Yeah. So I only want to give you 1. Yeah. 1 type. Yeah. That's the question number 5. Number 7. Yeah. Yeah. Can we always convert? Not always. Yeah. No. Yeah. Yeah. The reason pretty simple. Yeah. Because for most of the such questions, it's very hard to convert. Yeah. Only a very small number of questions we can do the conversion. Yeah. 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 So this also easy, very easy. Yeah. The third one also easy. No, because in the first one we do not allow x to be 0, not equal to 0, right? Yeah, because x to the negative third, yeah, you cannot let x be 0, but the second is okay. Yeah. Yeah. Then, based on this requirement, this property, these 2 equations are not equivalent. But when you solve the first equation, you can convert it to the second to solve. Yeah. It's okay, you convert second to solve. Yeah. But after you find a solution, then you need to check. You need to, if your solution, after you solve it, in your solution, you do not allow x to be 0. You need to, recover it. Yeah. Slightly, the second equation is slightly different from the first equation. So after you find the solution of the second one, you need to modify it to make it, to be the solution of the first one. Yeah. All right. Yeah. So that's the 3 questions I selected from quiz 1. Yeah.
Go back to 7.
Yeah. All right. Yeah. Always convert it to explicit form. Yeah. But not always, right? Yeah. Sometimes, and the percentage actually is pretty low. The percentage that we can convert is, pretty low. Yeah. Yeah. Yeah, because you may have, some very complicated case, right? Square plus, right? Right? Could be very complicated, right? How do you convert, right? Yeah, extremely hard. Yeah. 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 So in general, yeah, most of the time we cannot. Yeah. Only for relatively easier, simpler cases. Yeah. Right. Oh, yeah, these 2 cases. Yeah. So that's. But I wouldn't say only these 2. Yeah. Yeah. The questions. At this point, I do not know the the third one, the third case. I don't. Yeah. 2 we know. 2 we know. Definitely more than these 2. Yeah, but still unknown. Yeah. Unknown. Yeah. 2 we know. Yeah. Right. All right. Yeah. So that's the quiz number 1. Quiz number 2. We have 5 questions from this assignment. The first one. If the characteristic second order homogeneous real has 2 complex roots, complex solutions, then does not have any, it's false. Yeah. We know we can get the 2 equivalent sine cosine, right? Yeah. So here, the 2 complex, because the characteristic equation, lambda 1 negative half a plus omega I. Yeah. So we know omega I, equals some, yeah. Okay. Yeah. Lambda 2 minus omega R. Yeah. Then 2 complex solution. One is e to the lambda 1 and lambda 1t, right? Yeah. Second, e to the lambda 2t. These are 2 complex solutions. Yeah. But we can replace these 2 by 2 real solutions. Negative a over 2 cosine omega t, a to t, okay? Yeah. And t sine omega t. Yeah. They're 2 real solutions. Yeah. two complex solutions. These two complex. But these two real solutions. All right, so that's the point. Yeah. Yeah, non-trivial. Yeah. Next one. Yeah. This one, yeah, because non-homogeneous, so it should be R. Yeah. Yeah. So R of t, R of x. Yeah. Because we use x as the variable. Yeah. Yeah. All right. Yeah. I didn't notice that. Yeah. Then any particular, yeah, so it's true. Yeah. Any particular solution is a special case of its general solution. That means no singular solution. Yeah. This sentence tells us no singular solution. Yeah, that's true. Yeah. We have a theorem. Yeah. For second order ODE, we have theorem. Yeah. About that, this result. Yeah. Yeah, but I just need to, use that R. Yeah. R function. Yeah. Because non-homogeneous, so we should use R. Yeah. Yeah. All right. Yeah. But for homogeneous, it's true. Also true. Yeah. 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 All right. Question number 8. Yeah. Can we say that any continuous function must have no, right? We have a condition. Yeah. The condition I mentioned several times, yeah, that is absolute value. Yeah. Here we use variable x, m, e to the kx. Two constant, okay? Yeah. Yeah. All right. Number nine, we cannot. So here the initial condition not given at a 0 point. This tau not equal to 0. Yeah, we did example, by shifting operation. Yeah, so we can make it. Yeah, so we choose y tilde function t equals y function of t minus tau. Okay, because sorry, yeah. Plus tau. Yeah. Because in this way, y tilde of t at 0 point equals y of tau. Yeah. So you shift to tau. Yeah. But this value is given. That means y tilde function at 0 point is given. Yeah. Similarly, tilde derivative at 0 equals at tau, and it's given. Yeah. Yeah. And then you need to convert this function to the y tilde version. Yeah. Yeah. So when you convert, you only need to change the variable. Yeah, because variable you need to do a shift operation. Yeah. All right, so we have one example. Yeah. So you need to use that example to answer this question. Okay. Then this question, I'm thinking about if I give you one such question in the midterm. Yeah. Yeah, let me think about it. Yeah. One. Because in your homework assignment, I didn't give you this question, as I remember. I didn't give you this question. Yeah. So, yeah. Yeah, let me see. So when I grade your first homework assignment, let me see how well you do in the first homework assignment. Then I can make this decision. Yeah. All right. Then, yeah, so this is the question. You need to know that formula. You need to know that integral formula, Laplace transform, integral of this little f function equals capital F over S, right? You need to know this formula. Then you can answer this question easily. Yeah. Yeah, so the Laplace transform of function little f of t, that means capital F of S exists. Okay? Yeah. So then Laplace transform of the integral, yeah, this one exists. Yeah, you just divide it by S. You know, the result is this one. It exists. Yeah. 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 So then, yeah, it's true. Okay? Yeah. All right. Then, part 3, yeah. Select the questions in first 10 from. Yeah. I select 4 questions. 4 relatively hard questions. Yeah. But still not very hard. Yeah. Yeah. Still not very hard. Yeah. All right. The first one, yeah, this one, yeah, expression, yeah. So you just carefully calculate that, yeah. E to the negative natural log absolute value cosecant of x, okay, yeah. So you can write it as e to the, you know, you put the negative sign as a reciprocal, actually a reciprocal of cosecant. That's sine, right? Yeah. We know reciprocal of cosecant, that's sine. So that is sine x. Yeah. Then e and the natural log, you know, kind of cancellation, so you have sine function. So D is correct. Okay? Yeah. Yeah. So in one of our examples, we did this. Yeah, we need to use this. Yeah. Yeah. And yeah. Yeah, because so here sometimes, yeah, because I remember in that example, yeah, yeah, sometimes we need to use the, yeah, yeah. So because I remember that h, yeah, we need to calculate h equals, okay, yeah, sometimes we need to use this form, yeah, negative sign, because when there is a negative h, you need to use this form. But sometimes we need to use h equals this form. When you need to use h without negative sign, then you need to use this form. Okay? So these two forms, yeah. Sometimes you use the first one, sometimes you use the second one. Yeah. In one of our examples. Yeah. Any solution of the logistic equations can always be treated as a special case of the general solution of this. That's false. Yeah. Because logistic equation has a special property. So what's the logistic equation? That's the logistic equation. Okay. General solution of this, because there is a singular solution, logistics singular solution. That is y equal to 0. It's a singular solution. Yeah. So you may ask, how do you know the singular solution? Because the general solution does not contain the singular solution. General solution, something like, C times, well, yeah, what's that? Plus, something like that. Yeah, because the whatever. Yeah, let me just put something. Because the numerator is not equal to 0. So this solution can never be 0, okay? This solution can never be 0. But your singular solution is a 0 function. So the general solution does not contain this special solution, so we call it a singular solution. That's the one important property of the logistic equation. Yeah. All right? Yeah. Yeah, so there is another singular solution, right? Yeah, because this one you have a, you factor out a y 1 minus b over a y, yeah, another singular solution. So y equals b over a over b. Yeah. Oh, no, just a minute. Oh, yeah. Yeah. Oh, that's the. Yeah. Right. Right. Another. Yeah. But. Yeah. Okay, fine. Yeah. All right. Yeah. Okay. Any logistic must have. That's true, right? Because 0. At least we have that 0. This is singular. Yeah. So, and number 10. Yeah. So this is a relatively hard. Yeah, but not too much harder. Yeah. All right. Not too much harder. Yeah. So here the answer is C. Sometimes we can convert to separable, but sometimes we cannot. Yeah. Because in general we cannot. Okay? In general we cannot. Only in special case we can. Okay? Yeah. The special case, can you imagine this form could be some, yeah, let me use some constant, alpha y plus beta x to the nth power. If we can find some appropriate constant, alpha times y plus beta times x, it can be in that form. Yeah. Then you can make separable. U equals alpha y plus beta x. So u prime equals alpha y prime plus beta, right? So then y prime equals 1 over alpha u prime minus beta. Okay? That equals this function u to the n, right? Yeah, u to the n. So that's separable. Yeah. So this is separable. Yeah. But in some special case, it is separable. Yeah. In general case, not separable. Yeah. General case, yeah, it's very hard to separate. Yeah. The general case, yeah, because general case, although we can, yeah, so here, there is a special way to see the general case. General case, we can factor out y to the x to the n out. So a0 y over x to the n. So here, plus a1 n minus 1, okay? Dot, dot, dot. A n minus 1 y over x plus a n. Now, in general, we can do this way. So you can let u be y over x, okay? Yeah. Yeah. So then, y equals xu, y prime equals u plus x u prime, okay? Yeah, y prime. So then you have u plus xu prime equals n u function, right? Yeah, so here u function. But this one's still not separable, right? Yeah. That one's still not separable. So even you can write in that way, it's still not separable. Okay? Yeah. All right. Then, yeah, the last thing. Yeah. Yeah. Today we may leave a little earlier. Yeah. The last thing. Remember your quiz number 3. Do you have a similar question like that? In quiz number 3. Quiz number 3, I give you y prime equals p sub n x y over q sub n, right? Yeah. This one, yeah, separable or not? All right. Yeah. This one, can you use this way to understand? That way, yeah. Right. Yeah. Because in this way, your over q will be, because both one you can factor out, same x to the n, cancel out. Numerator, denominator cancel out. So what you have is, you have f of u over g of u, right? F of u over g of u. Then x is gone. Then this equals okay? Yeah. Now you can see separable or not easily, right? Yeah. So this one relates to one of your questions in the quiz number 3. Yeah. So use this as a hint for that question. Okay? It's different. Yeah. Although it looks pretty complicated. But if you can see this structure, then you can get it. Okay? Yeah. All right. Yeah. So that's the, review. Yeah. Only this question a little hard. Yeah. So here I give you, 12 questions, but only this last question a little hard. Yeah. But and here in this question, when you answer, you may not need to know this, right? You may not need to know the structure. But when you answer that similar question in our quiz number 3, then you really need to know the structure. Otherwise, you couldn't solve it. Yeah. Okay. Yeah. All right. So I want to stop right here. Yeah. Today we have 15 minutes earlier. Yeah. 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 The reason is that I couldn't find enough relatively hard questions here. Yeah. Yeah. Probably the quiz number 3 slightly harder. Yeah. Than these questions. Yeah.
So is this for the quiz part?
Yeah, quiz part. Right, part A and the quiz number 4. Right. Yeah. So, yeah, probably at the end of the spring break, I will post the quiz number 4 and the same time, same part A of midterm and the spring break.
And then we said the in-class is going to be, I think you picked the date, is it the 13th?
The, yeah, 20th. 20th, Thursday.
For the in-class.
Yeah.
Do you plan to do any review for that?
Tuesday review.
Tuesday review?
Yeah,
Oh, okay.
Tuesday review.
Tuesday when we come back?
Yeah.
Review for, okay.
Right, yeah, all computation questions.
Yes.
Yeah.
Okay.
Good. That's all we have before the spring break. So next week, remember spring break. So do not come to the class. Yeah, yeah. WashU spring break. Yeah, not AMSA. Right? Yeah.